So, welcome to Tuesday. We only have, see what, 3 weeks left, I think. Does that sound right? So I think we're going to be able to cover everything, hopefully. If not, I will adjust the assignments to where it'll all work out if we don't get to everything. So don't worry. So that last week, I think it's May, because the last day in here is, if I'm right, would be May 16th. Does that sound right? Because I think the last day of class is the 19th, if I'm right. So I think this whole week, this last week here, so the 14th and 16th is supposed to be finals, if I'm right. Does that sound right?
Yeah, I think so.
Yeah. Okay. So I haven't decided what to do for a final yet for you guys, because this class is we've kind of modified this class since you're using a new book. Last year you had, or the last few times I've taught this class, you had 2 hours to take a quiz, like a final quiz. I think it had like 50 questions or something. And it was open, and you had 2 tries, and it was open book, open everything. And then you also had about a 10-page like Word document that would have little questions, and you had to write pseudocode. It would say write a for loop to print out the numbers 1 through 10, or something like that. And you had to write it in pseudocode. But we haven't been spending a lot of time on pseudocode, so I think I'm going to change that up. Because, what do you guys think? I mean, we haven't done a lot on pseudocode. Do you feel pretty good about writing in pseudocode or not? Okay.
No, I agree.
Go from pseudocode.
Yeah.
We do better at it.
We spent a lot of time in the previous classes. They devoted a lot of time to pseudocode, but I haven't done that in here because I don't know. It is very valuable, but I didn't want to spend that much time on it. So I don't think I'm going to have you do that. So I'll probably come up with a little bit different final. So do you guys like quizzes more, like, you know, multiple choice answers, or would you prefer like having a code, like write some code that works? Quizzes? How many people like multiple choice quizzes for a final versus like coding, like writing some code? You like that, Nick and Natalie and Nate? All right. Maybe I'll mix it a little bit. Maybe I'll mix it up. Okay, cool. That's you. Good to see you, Micah. Yeah, keep coming to class. You guys are doing well. Okay, so let's look at this poll here. Okay, so just to review, and Natalie and Baron, good seeing you guys. Just to review dictionaries, and then we're going to be done with that, and we're going to get into strings today. But remember, a dictionary. Here's a dictionary called TLDS. I'm not sure why they named it that. So remember, a dictionary has a key and a value pair separated by a colon. You guys remember that? So, and it has a curly brace. So there's a key value pair, Canada, and that looks like the country code. And then United States, and then US, and then Mexico, and MX. So if I'm given this little dictionary here with 3 key value pairs, how would I determine if Canada is a key in this dictionary? Can I just say if Canada in TLDS, or would I say for I in TLDS.keys on the next line, if I equals Canada, the string, then print yes? And we got 10 people saying that's right. And that is right. This is also right.
Good.
This one will work too. You can try it. You can just use the keyword in, and that will work too. Let's test it out. You have a question? Let's see, hopefully this will switch over. Okay, let's create a little dictionary, TLDS. I'll just make a real simple one. Canada is my key, and my value is CA. I'll just make that. So that's my dictionary. And I can just say Canada in TLDS, and it says true, right? So you can do it like that too. How about CA in TLDS? Can I look for the value? Nope, just the key. Okay, how about, and if I say for I in TLDS dot keys, that's my keys function, or I'll just say print I. So that should just print Canada. Right, so I could say if I equals Canada, then I'm just going to print success, whatever. Okay, so there's kind of a last look at dictionaries. And we did a lot of stuff with dictionaries before. Alessandra? Okay, so Karen, I'm going to admit you. Good. All right, so let's go into what's due today. Oh, did I lose? Hang on a second. I got you. I think it's yeah, it slipped out of here. Hang on. It's funny. I was studying yesterday over in one of these other classrooms, and people had been in there, and somebody wrote Alessandra plus Carlos with a heart around it, but it was spelled with a Y. So I knew it wasn't you. Carlos isn't your significant other, is he?
No, mine is Luis.
What is it?
Luis.
We?
Luis.
Louise, okay. It was like Alessandra. So I guess some students had been in there just writing on the board. It was pretty funny. But I had never seen it spelled like that. All right, so what is due today? Okay, so today's Tuesday the 23rd. We're gonna start with strings, and we're gonna get deeper into strings. And strings are really cool. I think you guys will like it, and I've got about 3 in-class exercises for you. So what's due tonight at midnight? Module 9 quiz, I think it's 25 questions. The Module 9 interview questions, which, did we look at those yet? Let me double check what those are, I forgot. I think those are, oh, that's right here. Right here. Okay, this is weird. This is a screw up on my part. Adrian noticed it. The interview questions are the same as 6.1. What your lab is just these 2 exercises, 6.1 and 6.3. 6.1 is this. Briefly explain the operation of each of the following dictionary methods. And that's the same as the interview question, so you only have to do it once. Okay, so don't do it twice. And a hint, at my other class, my online class, I didn't get to tell them this, but I didn't realize it until I started grading their stuff. I'm going to tell you right now, not all of these are dictionary methods. One of them is not a dictionary method. If you were here earlier, I gave the answer. So you got the interview questions, which is this. If you do that, then you don't have to do 6.1. It's just the same question. Okay. So just to make it easier for you, who can tell me what this method does on a dictionary? We just looked at it, right? if I say for I in dictionary.keys, print I, what does that print out? The keys of the dictionary. All right. What do you think this prints out? Values, right? Now what does this print out? If I say for I in TLDS, I had that one that said Canada was a key and CA was the value.
Would it say both in a colon?
It returns both. Items returns both the key and the value. So in that case, you would say something like, if I had this TLDS equals, when I make a dictionary, I'll just call it, well, let's stick with Canada, colon, and CA. There's my dictionary. And then if I said for I in TLDS dot items, actually, sorry, we're gonna look at items now. So I would do, this is what most people do. They would say for K, comma, V in TLDS dot items. Print K and V. Okay. So this is going to return, and K is going to get the key, which is Canada, and V is going to get the value. So that's the key, and this part is the value. Okay. So that's what items is, right? So by elimination, by logical elimination, you might now know which one is not a method used in a dictionary. Okay. All right, so that's what's due tonight, and this is 6.3. The dictionary temperatures, here's a dictionary, contains 3 Fahrenheit. Let's fill this up a little bit. If we can. Temperatures, here's a dictionary, there's a key, Monday. So these are temperatures for Mondays, I guess. Maybe 3 Mondays in a month or something. 66, 70, 74. So this is a list. So the key and the value happens to be a list. Tuesday, Wednesday, and Thursday. So this is my whole dictionary. For key value in temperatures, dot items, remember that outputs the key and the value. I'm going to print the key and then the sum of V, because I can sum a list, divided by the length of the list. And I'm going to print it out with 2 decimals of precision floating point number. So you guys got to tell me what this code does. Okay. So not too hard. All right, so that's what's due tonight. What is due next Tuesday? Okay, so today's Tuesday, you got a whole week, and this is what's due next Tuesday. Module 10 quiz, okay, which we're in right now. Module 10 is strings. Module 10 quiz, Module 10 interview questions, and the Module 10 lab, which is exercise 8.1 in Dytel and Dytel. That's your book. Okay. And here is what it is. It's not that hard, but it's going to get you to think a little bit. This thing has some weird wrapping for some reason, but once you read it, basically, you guys know about when people like steal checks from the mail, and they have a way to put the check through some kind of solution that will erase a pin that you've written on it, and then they write their own amount in there. People like to steal mail, especially steal checks. So what this is going to do is you're going to be using the formatted print statement. We're going to look at it today. If you pay close attention today, you'll find the solution in today's class. But see how say we're writing a check and it's already been pre-written, pre-typed in by your HR or your, what would be the department, not HR, finance department. And say you got paid $399.87. And they printed it like this, but they left some spaces at the front. So some bad actor could take this and instead of $399.87, since they've left a couple spaces here, they could get a typewriter and write in 2 9s, right? And go cash that. Now instead of $399, they're getting $99,000. Okay? So your job is to figure out how to print that number with stars in front of it, so they can't put a couple digits in there. Okay. So this is what's due next Tuesday. Okay. So you're going to write a script that inputs a dollar amount like $33.87, then prints the amount in check protected format in a field of 10 characters. This one only has 7, or this one has 8. 1, 2, 3, 4, 5, 6, 7, 8. So you need to change it to 10 characters with leading asterisks if necessary. Okay, so that's what's due next Tuesday, along with your quiz, and then your interview questions. Okay?
Tuesday isn't today.
Hmm?
Tuesday isn't today.
No, next Tuesday.
Next-
This is all
next
due next
Tuesday.
Tuesday. Okay. I'm just giving you a preview of what's due next week. So pay attention today, and I think we're going to get to the solution for this problem. Okay, so today we're talking about strings and all the things you can do with strings. And we're just going to, these are our class objectives. We're just going to work our way down and look at some various things you can do with strings, formatting them, finding substrings, right alignment, left alignment, printing them out in different formats, and stuff like that. So that's what today and Thursday is going to be. Yuck. So any questions? That's better. Oh, this pen is like really got a lot of ink. Yeah. Like that. This works better. Yeah, there we go. Okay. All right, so let's start looking at strings. We've looked at them a little bit before. And then we're going to get into them in a little more detail today. And I've got like 3 exercises for you to do in class. Okay, so strings support many of the same sequence operations as lists and tuples. So you guys remember, if I have a string like, say I say x equals a, hello. Right, so this is a string, right? I can surround it by single quotes or double quotes. Same thing. I could say y equals yesterday, whatever. Right? So both those are strings. And we looked at strings already. So you can do something like this if you guys remember. This is also like an array. It's kind of like looking at it like this, like a list with H, E, L, L, and O. You can kind of look at it like that in a way. Because I can say for I in X, print I. Right? So I'm saying for I in X, I'm going to print, and it's going to go print each of these letters out. So strings are kind of like lists as well. Let's try it. Okay, so X is hello. for I and X, print I. And you saw it just printed out hello, one line at a time. One letter per line, hello. Okay, so these strings act like lists, okay? Just remember that. Or arrays, okay? We know that strings, like tuples, are immutable. You couldn't say, so we're talking about strings today, just to be clear. So I couldn't do this, right? I couldn't say X sub 0, the first element right there, equals a capital H. I couldn't do that, right? Because they're immutable. I can't change that string. Okay, that's what immutable means. Okay, so just remember that. And then we've been doing formatted strings for quite a while, but we're going to get a little bit more into it today. So you can just type, we've been typing stuff like this. Print, a formatted print, we put F in here, and then that single quote, and then we could put like X in here in curly braces. And we could put a space, and I could say Bill, whatever. And then we end that. So this is a formatted print. So what's this going to print out?
Hello, Bill.
Hello, Bill. Yeah. So this is how we can format. It grabs, when you put curly braces around a variable, it just puts the variable right in here. Okay. So this is just going to print out hello, Bill in lowercase with a space, because we put a space there, Bill, and it always outputs a string. Okay. So we're going to look at, instead of putting this inside a print statement, we're just going to use the F part of this just to demonstrate. So we're just going to do stuff like this for some of these examples. We're just going to ignore the print part, and we're just going to use this little formatted part right here like that. Okay. All right, so here's one, a formatted string. We put 17.489. That's the number we want to print. And then the colon is going to tell us how we're going to format it. 0.2F, what does that mean? What's 0.2 mean?
Rounding.
Rounding. We're just going to print it with 2 decimals. And why did it go to 9? Why did 17.48 go to 0.49?
It rounded up.
It rounded up. Why is that? It looks at the next number, right? Past the 8. If that's 5 or greater,
Yeah.
it makes that one go up 1. Okay. All right. So let's play with a couple of these. So there's all these different things that we haven't looked at yet. There's a F for floating point. There's a D for integers. There's a B for binary, an O for octal, an X for hexadecimal. We haven't looked at that yet. And a C for character, and an S for string. So we can format all these things. So we're gonna do this. We'll say, what was that, 17.489 colon 0.2F, right? Whoops, I forgot this. There we go. And it said 17.49. So what if I make it 17.483? What do you think it's going to do?
Those should print out 17.48.
Yep. Good. You got it. All right. So let's look at a decimal now. So on this line, so that's the way you format floating points. If you put a D there, it's going to print out the 10 as a decimal now, as an integer. Okay. So let's try that. And then we're going to substitute B, O, and X and see what happens. So let's do F. And we did 10 as a decimal. And that just prints out the string 10. Now, you got to realize, every time you print something out, it prints it out as a string. not as a number. Even if I say, right here, I said print out, I'm gonna have a formatted string, the number 10 as a decimal, and it printed out 10, but it prints it out as a string. That's not an integer. You couldn't add that to 5 or something, okay? Everything that's a formatted, it always prints it out as strings. And every number that's in a file, if you're gonna read data from a file, like a CSV file or something that has a whole bunch of numbers, they're all read in as strings. They're stored as strings, not numbers, unless it's binary. Okay, so let's try this. So that's a decimal. Let's try, did we go over octal characters at all? Or let's look at binary first. If I put a B there, it prints out binary. Okay? You guys remember when we talked about binary? Anybody at all? So it says 1010. So we're trying to print out the number 10 in binary, and it says 1010. And remember, this is, in binary, this is 2 to the 0. This location is 2 to the 1 times that, if it has a number. This is 2 to the 2, which would be 4. And this is 2 to the 3. Okay. So 2 to the 3, since there's a 1 there, what is 2 to the 3? What's 2 times 2 times 2?
6.
8. Plus, there's only one other 1. What's 2 to the first power? 2. So 8 plus 2 is 10. So this is the binary representation of the decimal 10. Okay? So just by putting a B there, you can get binary out, which is pretty cool. And then I don't think we looked at octal, but we can look at it. That's another numbering. If you put O in there, it prints out octal. And octal, I'm gonna write over here. Let's use my black one. Has anyone heard of the octal numbering system?
Must have to do with eights.
Has to do with 8. Yeah, exactly right. So octal is base 8. Base 8 numbering system. What is the base of binary?
2.
Base 2. Okay, so this is binary, which is base 2. What is our normal decimal system?
Base 10.
Base 10. Yeah. So this is a decimal. This is base 10. So base 10. Okay. So let's look at octal just for a second. I mean, we don't need to belabor this, but this is octal is base 8. Like oct means 8. Like October is not the 8th month, but I think it came from that Greek word right there. Oct stands for 8. Means 8. So octal goes like this. You have 0, 1, 2, 3, 4, 5, 6, 7. Okay? And that's all those are the only numbers you can use in anything. Okay? And what number did I give? 10. Okay. So these are the only digits that are used in octal. And I had the number 10, and I said, I want it in decimal. What is that in octal? So it's just like the way we did over there. This would be 8 to the 0 power plus, is that right? Plus 8 to the first power. And it printed out, 12 and, sorry, my bad. It printed out 12, didn't it, in octal, my bad. So 10, it printed out 12 in octal. So this number, this digit here is 8 to the 0 if it has something in there. And this would be 8 to the 1. So 8 to the 1 is 8. 8 to the 0 is 1 times 2 is 2 equals 10. Okay? So 12 in octal, I'll say octal, is 10 in decimal, which would be base 10. I could write this base 8 if I wanted. You write level 8. Okay. So just by changing this, so I got decimal, floating point decimal, binary, octal. There's one more numbering system. Does anybody know what it is? I'll use a big X. Hexadecimal. Okay, so hexadecimal, what does hexadecimal mean?
It's for like colors, right?
This means base 16. Yeah, it's kind of weird. So it goes like this. You start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you go A, B, C, D. So this would be 10, 11, 12, 13, 14, 15. And there's a 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's base, hexadecimal is base 16. Okay? So I said let's print out 10, or no, what did I say? 10 in hexadecimal, and it gave me A. Okay? So A would be, you could see that it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is really 10, 11, 12, 13, 14, 15. So you can see when I printed 10 out, it's A. So let's try 11 in hexadecimal. That's your printout B, right? So we don't need to belabor that, but I wanted to show you that that's some different things you can do when you print. We also have character. So this is one of our class exercises. So let's try this for a second. This line right here. What am I doing right here? I'm doing a formatted print, and I put the number 65, but I say character. And I put the number 97, and I say print the character. And it prints out, so 65 prints out a big A, and 97 prints out a little a. What does that mean?
Is it AC characters?
ASCII, yep. Because every letter has an integer in the ASCII table that is related to it. If you look up ASCII, just type it up in a web browser, it'll show you all the characters, right? So this is a way to print out the ASCII character, the ASCII number as a character, okay? And we're going to use that later in one of our exercises. And if you use an S, it prints it out as a string, and the string is default. It always just defaults to S. So I'm saying print hello, format it, print hello, string hello as a string, and then I'm printing 7, and that converts the 7 into a string, and it just has hello space 7. 7's converted to a string. Okay. So let's look at a couple of those examples real fast. Let's try.
Oh, I'll be right back.
What do we say? 97 as a character. There's lower A. Let's try 98. Lowercase b. So these are all ASCII, right? And if I go to, let's see, do I have a web browser open over here? Okay, here we go. Here, let me make this bigger for you guys. I just typed in ASCII. A little bigger. Okay. Let's see if I can move this over. There we go. Okay, move it up a little. There we go. Okay, so here's an ASCII. This is the ASCII table. So here is A, capital A, and in decimal, it's the number 65. Here's hexadecimal and octal. And this is how you would print an A in HTML. So these are showing you all the representations. They didn't show you a binary. Would be too long. So 65, so A is really represented inside the computer by the number 65. Little a, lowercase a, is 97. Okay. So this is the ASCII table, and it also prints out some other, like left parentheses, right parentheses, ampersand, percent, dollar sign, a pound, double quote, bang. It has some other, here's a single back tick, here's the @ sign, is 64, and there's more to it. So I'm going to ask you guys to do something later with some of these other characters here. See how we have the colon here, semicolon, a less than, an equal, a greater than, a question mark, right square bracket, backslash, left square bracket. This is called a hat, this little pointy thing, underscore, left curly brace, a bar, right curly brace, a tilde. Okay. Asterisk plus, a right tick minus, dot, /. And then some of these other things are things you can't even see, like an escape character. These are things that are like a tab character right here. 9 prints out a tab. It's white space. You don't see it actually. Okay, so let's try that just for fun. What was a tab? 9? So let's print out 9 as a character, and it prints out \t. So that's a tab. And we want to print the string hello as a string. And then we want it to print, let's see, so that just prints out hello as a string. And what was the other example? I think there was as a string and then 7. Okay, good. So this is going to put those two together, separated by whatever we want to put in here. Hello and 7. This combines the two strings. Converts 7 to a string. Here's another pretty cool thing about, we can import decimal, and that's for dealing with money, remember? So if I do this, I'm going to import decimal. From decimal, import decimal. And then I can print out some big, giant, long numbers. Let's print this out. And this is saying print this 1 gazillion whatever with 3 decimal points. Right? And there it did. It printed it out with 3 decimal points. I know this is low down here. That 0.3f did that. So it printed this whole number out, and instead of 1, it added 2 more. And then we could print that in exponential notation too, or scientific notation, if we use the E. Okay, let's try this. So this would be 1 point, so there must be 25 zeros there. Let's see. Whoops, I didn't copy it. No, I didn't. Okay, there we go. So that's 1.000 times 10 to the 25th. So there's probably 25, there must be 25 zeros here. 1, 2, 3. 1, 2, 3, 4, 5. Yeah. So this is saying 1 times 10 to the 25th, if you guys remember that kind of scientific notation. That's how you can do that. Okay. So there's a lot of cool things you can do with formatting in Python. Let's see, where's your first exercise? Okay, it's coming up. Okay, let's look at, you guys remember field widths. And in all these exercises, we're printing out, we're doing a formatted print, and we're putting square brackets in there just so you can see the spaces. So we're saying, I want to print 27 out, and I want to print it with 10 total spaces, okay? And this is automatically going to be right justified. It's a decimal. So there's really 10 spaces in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that 10D is saying that's the number of spaces, and I want to print the 27. Here's a float, 3.5. I want to print that out in 10 spaces. So it does 3.5, and by default, a floating point number. So they didn't put 10 point anything for the precision. It automatically defaults to 6 decimal points. So if you say just 10F or 2F, it's automatically going to go 10 if it has a space. So this has 10, so it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, right justified. Here's the string hello in 10 spaces. It puts strings left justified by default. So this is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you remember how to force it to do left and right. So here's 27 in 15 spaces as a decimal, and that little less than forces it to the left. So that's the same as this almost, except we're printing this one in 15 instead of 10, and we're making it flush left. Here's 3.5 in 15 spaces, flush left. So it's almost the same as this. It has 6 decimals. 1, 2, 3, 4, 5, 6. So it's 1, 2, 3, 4, 5, 6, 7, 8. And there should be 7 more. 9, 10, 11, 12, 13, 14, 15. Okay. Here's printing the string hello. Flush right. If we use the right, the greater than sign, it prints it right in a field of 15 characters. Okay? You guys kind of remember that? With the less than and greater than, how we make it go left and right. And then if you want to center something, you use the hat. Okay? So I want to center the number 27 in a field of 7. So this really has 2 in front and 3 after. You can see it's over a little bit. So it tries to center it as best it can. So there should be 7 whole spaces here. 1, 2, 3, 4, 5, 6, 7. Okay? This is how you can, if you want to print a plus sign, if it's a positive number, you just put the plus in there. So I want to print the number 27 inside these square brackets and a field of 10 as a decimal, but if it's a positive number, I want to put a plus sign in front of it. So that's how you do that. Okay. So this is just like this one up here, except we added the plus right from that. And this is another pretty cool trick. So think about this right now to help you with your assignment. This is going to print a plus sign, and if I put a 0 in front of the 10, so I'm saying print 27 in a field of 10, I'm going to print it as a decimal, but I want, if there's any spaces to the left, I want to put all zeros there. So this printed a plus sign, all zeros, and then 27. This should be total of 10 spaces. 1, 2, 4, 5, 6, 7, 8, 9, 10. Okay? So that might help you with your assignment. Something like that. Here's one more. We're almost getting to your point where I want to give you guys a little assignment. If you want to show the comma as thousands separator, like this, to separate the thousands, we want to print it out. So I want to print the number 1, 2, 3, 4, 5, 6, 7, 8, which would be 12,345,678, colon, you just put the comma there, make it a decimal, and it'll automatically put the commas in for you and make it nicely formatted with commas for the thousands separators, okay? Okay, so these are all formatted. This is in new Python. This is Python 3 point, what we're in right now. Back when Python was version 2.7 and 2 point whatever, they didn't have this formatted string. This is something new. So this is the way we had to do it in the old days. I'm going to erase this if I can. Oy. What's up with this ink? The blue one is like, doesn't like it. Maybe I'll go with the black one. So let me show you how to use the old format method. Okay, which is pretty cool, and I think you might need to use that for your exercise. Okay. Okay, so the old format method, you put your, let me scroll that up a little bit. You actually use the word format. Okay. So this is how we used to do it if we wanted to format something. We would say, we would put our string here, and we don't use an F anymore in front of it. We just use the string, a colon, .2f, dot format, and then we put the number in. So that number goes into this curly brace here and formats it out. All right, so let me write this out here so you can see it. So it's colon, .2f. There's our little formatting, and then we put dot format, and here's where we put our number, which was 17.489. Right? So this is the old way we had to do it. And this is going to output, we already saw, it's going to do it 2. It's going to look at this number, which is greater than 5, so it's going to round the second one up because we're only going to print 2. It's going to print out 17, the string 17.49. Okay. Now here's another way to do that with just leaving these things blank. So we can just put curly braces that are blank. We could put a couple of them. Dot format. And then since these are 2 empty ones, it's looking for 2 arguments in here, and I think they're using Amanda and Cyan. A string Amanda and another string Cyan, a color. Okay. So it's going to pop Amanda into this spot, have a space, and it's going to pop Cyan over into here when it prints it out. So it's going to print out Amanda, space, Cyan. Like that. Okay, and here's one more. And then you're going to do an exercise and see if you can figure this out. So we got a colon, that's going to tell us what our format. We got a plus sign. Right justify 12.2 F dot format. And we put in 11.256. Okay, so what we're saying here is we're going to write justify in a field 12 characters long. 3, 4, 5, 6, 7, 9, 10, 11, 12. And we're going to print this number out, but only with 2 decimal points. So is this 5? We're looking at this number, it's greater than 5. So it's going to round this up to what?
11.26.
Yep. Point. So it's 11.26, right justified. And this plus sign means we're going to fill up all these blanks with pluses. Okay? All right, so here's your exercise. I want you to use this positional formatting just like we did here, and also to print out this emoji. I want you to print out this. It's like a smiley face, kind of, but he's kind of looking like a little hat. Right? Looks like a little man. So this is 3 characters, right? There's 3 different characters here. I want you guys to figure out how to print that out using this type of thing. So here's an example for you. You need to look at the ASCII table, and here's a way just to print out a single, this would be a way to print out a single question mark. We would say print, we have our format, :C for character, dot format 63. So 63 was the question mark. So that prints out a single question mark. Okay? So you want to print 3 things out. Okay? So you're going to have 3 arguments in here. And try to get this little smiley face man. So take like 5 minutes, however long it takes you to do that. I'll walk around and help you. And then you can take a break after that. So I would open up the ASCII table and look up what number this is, what number that is, and what number that is. That's what you're going to need. We know 63 is a question mark. What? ASCII. Did I write that? I probably didn't write ASCII. You need to look up this. ASCII. ASCII. What is it? American Association for Computer Information Interchange? Yeah, so raise your hand if you have a question. It shouldn't take you too long.
I think that's the way we have to do it.
Oh, you got it? Good.
Yeah. But yeah, you have to look at that.
Oh, yeah, I never pulled out this.
Okay.
Yeah.
Yeah, I'm gonna try it out.
Let me see if I can erase this over here. God, somebody needs some new erasers. Maybe I should go get a new eraser today. I think it's an eraser. All right, so to print out just a question mark, I would do print, and we're doing the format, right? Or actually, we're going to use the old format method. So we don't put an F. And here we're saying, should be :C. Is that right? Yeah. Because we're just going to print a character, and then dot format, and then here we're putting in the number that we looked up in the ASCII table for a question mark. So this outputs prints a single question mark. Okay. What we want is 3 characters: the colon, the little hat, and the right paren. Yeah, go take a picture of it. Not sure. Oh, you need one more print at the end.
Okay, I think, I mean, you do it that way, I'm trying to do it differently, be like, yeah, like, I'm doing the F method, that like the old fashioned way. But yeah, I think if you do that, you need like 3 different numbers, you know how we need 3 different symbols from the ASCII chart? So like,
Oh, it's
you can need
probably
58, 94, and,
bigger number.
you know, find out the last step, and 41.
That's a,
Yeah, yeah, you can try that way, I wanna try my own, see if it doesn't, then I'll try.
So now, plug in one of the numbers that we gave for that print. Oh, yeah, the colon. Okay, good, so you got that. So how would you print 2 characters out? Yeah. Yeah. For every one. A whole nother. There, yeah. Kevin. Richard's just about that. Yeah.
I did the other way, using the F.
Yeah, yeah.
Yeah, Jim.
Yeah, good. 58, 94, 41. Okay, that's fine.
Oh,
That works.
okay.
Good. Oh, sorry, Nicholas. I didn't-